Hello, everyone. My name is Javier Mancilla, as you know already. I am here to present Falcondale. I'm the CEO and co-founder of Stafford Computing, but here I'm presenting Falcondale that soon will be an independent company and will be incorporated in the following months. What do we do? Is leveraging, implementing, adapting quantum simulated capabilities for the current state of machine learning models in the finance sector. You can call it credit scoring, fraud detection, and things like that. Let's see a little bit more about the problem, what we're looking to solve. Typically, journeys of fintechs, neobanks, and banks start, for example, in the case of fintechs, we develop a product, they are creating POCs, but suddenly, they are struggling in a challenging scenario to adapt their services to different data complexity solutions, markets, segments of clients, and so on and so forth. So the difficulties appear. They reach this Barren plateau, in the fintechs, of course, that are using machine learning models to keep improving their models in terms of AUC, Gini, depending on the case. And in the case of traditional banks and neobanks, they want to develop their own scores or grab scores from other providers. What they are doing, they start scaling, giving loans, credit cards, lending in general. But suddenly, again, the performance of the models are not increasing. And I'm saying this from personal experience. I work for more than 6 years now, working with neobanks and banks implementing ML and QML solutions. So the difficulties appears again. What are the next steps? It's a little bit faster, right? It's more data, it's a different machine learning model approach, what they need to do, what is the right next step. So we are going to ignite the next step. We are the extra mile using quantum machine learning in a simulated environment. So here's the example of what we do. We have the AUC in the vertical axis, which is 0.5 is just random guessing, and more than 0.80 or 0.90 is a pretty good result. The AUC is there under the curve, and it's a typical measurement for machine learning models in classification. So what do we have? If we just implement a quantum support vector classifier, typically with a vanilla implementation, we just have an AUC below 0.60. This is the case of a classification model for defaulters to predict default or not in a credit card environment. So what happens if we use support vector machine classically, right? What is the best performance? Below 0.70. And what happens if we use the state of the art, which is XGBoost, gradient boosting, CAT boost is the gradient boosting in general. They reach more than 0.70. This is a real case with real data sets. So what we can do, simulating just with 2 qubits, the classical methods are using all the features. We are just reducing the features to just 2, using 2 dimensions. And if we add clustering, a linear discriminant analysis in the reduction of dimensions and preprocessing, we are getting a little bit of advantage compared with the vanilla installation. Then we have automated feature map design. Then we have our specialty and secret sauce, the quantum kernel optimization. And we reach more than 0.80 using Falcondale with the solution that I'm presenting today. So what this means, the state of the art is gradient boosting. And if we add this extra margin, the losses in default will be optimized. And this will be extremely convenient for neobanks, banks, and fintechs. And here we have the specs of the test. We have 2 products, Viable Quantum System Kit, and we have Systemic Quantum Score. What this means, in the case of Viable Quantum System Kit, we know that the banking sector wants to create their own scores. They want to create their own systems. So we provide a suite of tools that they can use to develop their own scores. We are not replacing their systems, and this is very delicate because they need to use data as well that they don't want to share outside their systems as well. And we have the financial institution proprietary score with what? Higher AUC, with still proprietary decisioning system and business advantage. What else? With BQSK, we have this middle ground. In terms of, okay, they're providing company data, the insights, and so on. We provide the quantum-inspired, quantum simulated solution, and now we have later the data science team working as regular with machine learning and classical methods. And SQS is the whole package. So they will grab the score completely in one package, and we're consuming public records, open banking, financial behavior, credit bureaus, and alternative data to produce a low-effort score and a top-tier guarantees one. Here, this is the point that I describe what our solution do with kernels. So using the high dimensional regimes simulated for now with 2 dimensions, we are capable to discriminate in this fuzzy area who are the defaulters and who are not defaulters. And the other important thing is that our designs, our systems, the architectures are designed to work in these machines, but simulated. But what will happen with quantum advantage appears in post-NIC or fault tolerant. So we will increase our performance because we just need to switch from simulators to NIC machines, or post-NIC machines in this case, or fault tolerant. So typically, Quantum Inspire will work with tensor networks, and we will work with these machines. We're currently working anyway to see how this can perform with fermionic and OQC, and see if we can emulate correctly our models, and see if they can run, and we can grab a little bit of advantage in the NISQ era. Secure by default, we know that our clients are concerned about security, so we want to be SOC 2, Type 2 compliant, and also have ISO 27001. And this is...
Switch to the question and answer.
Okay.
Okay, thank you.
Do you have...
I think the mic is not on. Sorry.
There we go. All right.
That's it.
Do you have, are any of these, the banks that you would work for, are they investors, or what traction have you had with customers in that space?
Yeah. Actually, we have a joint venture now. This is, again, this Falcondale will be incorporated. So it's a joint venture between Stafford Computing and a company in LATAM that have more than 10 years of experience in fintech and banking sector. So we're grabbing all these clients that Stafford Computing already have. We have more than 4 clients in neobank and banking sector in general, and also with this LATAM company. So, and we have investor interested from Singapore and from Chile.
Thank you. And this is written in Qiskit, is that right?
We are working with Qiskit and Penny.
Okay.
Yes.
Is it, what do you see as barriers to entry to get, for others? If this is built on top of Qiskit, how do you stop others from building the same kind of thing?
Yeah, because we're using, of course, the SDK as a main framework, but the things that we're developing are completely different. So we are developing our secret sauce. We're developing a new way to optimize quantum kernels. For example, multiple kernel learning that will provide us not only advantage with 2 dimensions, but with more than 2. Okay. That's the approach.
And you were working in this area before. Is there any issues with the IP? Did you develop some of this while you were working for another bank, or do you have full ownership of it?
No. For now, we're managing secrecy, but in the future, we want to, of course, if we have a really customized approach in terms of the secret sauce and how we're managing the quantum kernels, we want to protect our IP correctly, of course.